Hello and welcome back to the lab. Today on the bench we have a Type 130 LC meter, not LCR, just LC. So it's an inductance and capacitance meter from Tektronix. This particular instrument is of the vacuum tube era, so we're going to be doing some tube work. We have the accompanying S30 delta standard that's needed to do the alignment on this meter. Now, the reason this is called a delta standard is because it's not a definition, but it's a definition of difference, if that makes sense. So, if I turn the knob here, we can see 0 picofarads. But then if I kick it here, it's -3 picofarads. So the alignment for the 130 needs a delta standard, not just straight standards. This particular unit has a UHF plug on it, and so does the delta standard. These are actually matched, so they'll sit next to each other while doing the alignment. For my usage, most of my test equipment is BNC, so I needed a UHF to BNC adapter. This is a high-quality Amphenol plug. So we are good there. Cosmetically, this unit is in amazing shape. There's very little scratches on the meter, almost no dents on the case, lots of dust though. So we're gonna have to give it a good cleaning. We'll pop the side panels off, take a look at it, see if there's anything in here we need to restore, replace, and get up and going. This meter, I don't remember exactly how this came to me, but the standard I had to pick up separately, so they did not come together, which was fine. Standard's got a little bit of a punch in the top of it, but it should be good. The first thing we need to take care of is I need to take care of the tarnish that's on this pin and clean up these connectors, both of them actually, now that I look at the UHF on the LC meter. It's kind of corroded. Not like it was in a caustic environment, but just time corrosion. It's gone from bright to dull. So I'm going to get the connectors cleaned up, and then we'll take the covers off. Okay, after a bit of cleanup and a little bit of coffee, that is looking much better than it was. So I'm going to get the camera repositioned. We'll get the covers off. This unit may have very, very low time on it. We have a tag on here. That is the original tag that ships with the unit when you get it from Tek. So this unit might be a time capsule. We have serial number 11034, which is fine. Pull this off for now, but we'll definitely save this for our records. And back from a time when people actually signed off on work they did. So, to get into these, it's relatively easy. Okay, so, and we're in. And we find exactly what I expected. So, we have ceramic strip construction. Get a small pointer screwdriver here real quick. So we have ceramic strip construction. I do have the air compressor turned on. We are going to be doing this under some nitrogen. We have a couple of domino capacitors. These could probably stay. I question these. These might be paper. If these are paper, they have to go. These electrolytics will get replaced. Let's check the other side. There are the vacuum tubes. So it should be noted at this point, anybody who's opening the panels on a piece of vacuum tube equipment, these are, if you see tubes, assume high voltage. B+ in vacuum tube equipment, depending on what you're working on, can be upwards of 3 3,000 volts for, say, ham radio transmitters, things like that. This is probably running around 450, 350 for a B+, still very elevated, about 4x what comes out of my wall. So definitely take care. And if you're not familiar with working on this stuff, please get some help from somebody who knows the ins and outs and the hazards. Especially with some of this stuff, it can be very, very unforgiving. So with high voltage and things like that, you got one shot, and if that gets messed up, you might not wake up. Definitely take care. Okay, so for our coarse tuning, we have just a tuning capacitor and a single plate tuning capacitor for the fine tuning. Not a problem there. 2 current transformers. We got T30, T1. This would be a power transformer. Probably bulk filter cap. Have to see what rail that's on. That may or may not need changing. Typically it doesn't. These aren't switch mode power supplies. I change them out just so they don't leak over things, but electrically those caps are still good, so it would be your option for your equipment. These switches are definitely going to need some cleaning. Wow, that's bad. So here's one of the wafer switches. You can see this very heavily tarnished contact. These will need some cleaning and exercising. I'm sure the switches are going to need lubrication, and the mechanicals are going to need lubrication as well. If I could find a BNC that has this same wall plate, this could be easily swapped to a surface mount BNC jack if I found something with a big enough surface. I have done that with the Type 106. The output on that, I put a metal plate here, put a panel mount BNC in there, and then, because it's just the one leg. So this could be easily changed. I would have to see if the standard could be easily changed for a BNC as well. And if that's the case, I may do that. I'm not 100% sure yet. All right, what else do we have? These would be the power transformer taps, line fuse, plug. These plugs, this was Tek's original style plug. This is not a problem. I have an extension cord that I can just plug in here and it will be fine. No problem there. We do have a little bit of paint peeling off the back, but nothing major. I don't have a paint booth yet. That's going to be something for a bigger shop. I need to work on the dirty side of the lab. I've got the clean side pretty much squared away, but I want to get into some chassis building, chassis restorations, things like that here in the lab, not just other places. So for that, I need to work on the dirty side, which will be modest machine shop and fab. But all things in time. When working on these with these ceramic strips, just know that you do need to use a silver-bearing solder. We are going to use that. I found a lead-free solder that has a high silver content. Something over 3% silver if you can find it, but as much silver as you can to work on the ceramic strips. The heat and the lead solder can pull the silver out of the ceramic, and that'll cause the saddle to pop off. Usually, that is so important that Tek usually put a roll of solder in some of the equipment. I don't see it on this one. No. But in the scopes, you'd have actually a roll of silver solder that they use to put them together. Let me dig up the service manual for this. I want to check these caps, see if we need to replace these. If we don't need to replace these, and these are poly capacitors, that would make this restoration go a lot quicker. Okay, after consulting the service manual, we get bad news. Well, some good news, some bad news. These are mica, so those are going to be fine. These were electrolytics as we expected. We know the one down there's an electrolytic. These are paper. So they are type PT, so they will be coming out. These are turning into resistors and are well past their fresh date. They need to go. The band here is the outside foil end of the cap, so we'll need to orient the new caps in the circuit the same way. But needs to be replaced, needs to be replaced, needs to be replaced. this one, this one, this one, and this one. So I will have to see what I have in stock. I'm not 100% sure I have all the values we need, so I may have to order something. Well, as with everything, the plot has thickened. So I was looking at a different service manual, and it has all of those capacitors listed as ceramic. And I was also poking around in some older pictures. This is a pretty late model unit. The older pictures definitely do have paper capacitors in this position. However, the newer service manual says there are no paper capacitors in the unit. They were all transitioned to ceramic. Doesn't tell me what serial numbers that service manual covers, but we have ways to test things in the lab, so I hooked it up to the SMU and was going to do a leakage test. Now I'm a little limited there. I'm going to move it over to my IT28 because the SMU tops out at 100 volts, but I wanted to see what the SMU would because it's a very good current source. And, of course, the plot thickens. Moving you guys up to the SMU, we're putting 100 volts across that capacitor, and we have a leakage of 36 picoamps. So that might be a ceramic capacitor. If so, they can stay. Moving up to our IT28, we will check, we'll set it for paper, mica, etc., which is the most sensitive range. So this will, if I remember the spec sheet right, this will pass it at, I think it's 2, 3, and 5 microamps of current. So if the cap's passing less than 2 microamps, it should pass in the paper, mica, etc. range. Wow, I need to clean this. Ugh. We'll hit it to leakage, and we have no leakage to speak of at 3 volts, which we expected. No leakage at 300, no leakage at 350 at all. So if I discharge it and I hit it to leakage, zip, and it's testing as a good capacitor. So I'm going to post a picture online. I'm going to ask the hive mind their opinion, and we will go from there. Testing indicates it's a ceramic capacitor and it can stay. If that's the case, there's not really much to do in this, but we will see. Okay, after consulting with the hive mind of the internet, these are all the same series of capacitor. I've seen pictures where these are Black Beauties and a couple of others, so they didn't use a mix of capacitors in this section. However, I'm going with these are film-based caps and do not need to be changed out. However, this one and this one does. The other thing is looking around, there's a capacitor right here. The unit's been off for a very long time, and I have not plugged it in yet to test it, so we're going to do that on camera. But that one is showing some corrosion under here, so we do have to do a little bit of ceramic strip work. I did need to get the air compressor all fixed up. I had it turned on because I was going to use the nitrogen iron, and I wasn't sure 100% what was happening because it wasn't turning off. And I went up and checked the pressure level. It only had like 40 psi in it. It should have 200. Found this brass collar, or this brass coupler in the air system, split dead in half. Now, I checked the pipe. There was no ice in it or anything like that, even though it's cold. Winter's raging at the moment, so... But, yeah, just completely split in half, and that was my air leak. So, the compressor's up. I've got gas flow, so we can do some N2 work. And I'm going to pull this cap out, and we're going to check that one right now. Iron's going to come in on this side. I'll pull the line out from the other side, and we'll go from there. All right. Been told you guys like to see the soldering work, so we're going to try to do that some more in some future videos. Sure we don't blow the hot gases. Right now I'm just tinning the tip with the lead or the silver bearing solder. I'll do this a few times, really clean this tip off. The jet that you're seeing flow by to blow the flux fumes away, that is the actual N2 gas flow. I have the gas regulator set to about 1.5 liters a minute. which isn't too bad. I am well versed in industrial safety and a few other things. If you are going to play around with compressed gases in enclosed spaces, know the hazards there and everything that goes along with it. This is not out of a nitrogen bottle. This is out of a oxygen filter. So the O2 that would otherwise not be present if it was a nitrogen bottle is dumping into the room. So I don't have I don't have a problem to worry about breathable gases, but it could potentially be a problem. I'm going to burn my fingers. It could potentially be a problem if I was using a nitrogen bottle. There is a definite concern of asphyxiation. Come out. There we go. We will also turn on the gun, because coming in the side with the desolder gun actually cleans the saddles out really well. And we are using some, come back here, Kester lead-free. N2 is very much not necessary for a lot of this, but it does helps the joints with some preheating. It also helps with cleanliness, because you don't have the O2 coming into the bottom side of the joint. There we go. So it helps keep the joint clean. I know some, when I was doing the research to see if I wanted the N2 system, well, that just goes to ground on the other side. But it's in between two tubes. All right, we'll pop this tube out so it's easier for you guys to see what's going on. Using the non-N2 iron. Get this ground lug out of here, and then we'll hit this with the desolder tool to clean that hole before it cools off too much. Perfect. Now let's pull this capacitor out of here. See what we got. There is some corrosion on the back side of this cap, which is why I want to get it out of here. We have a bit of corrosion starting on the back side, and this is an electrolytic capacitor. So positive goes away from ground, which is easy enough. It's a 300 volt cap, so let's see what the lab has. Well, that's convenient for an odd value. I had a 6.8 450 volt cap, and this is a 300 volt cap, so that's going to give me a 150 volt buffer, which will always be good. Now, when you're working with tube gear, one of the things that's weird, during power up, the voltage can go sky high. Well, older caps, that was allowable. Modern caps, they get really cranky about that. Okay, getting the wire done. My apologies for not turning on the camera sooner, but okay. There's the solder joint. Now we just need to put some heat shrink on it. At the moment, the lab has eaten my micro torch, so we'll need to use a bit more fire than we normally use. Alright, we'll let that cool before we snip it. We have the negative lead here, positive lead is going down through the wire on the other side, and the cap's getting some support from the plastic standoff. That is the way the standoff pushes through to the chassis, so this will be nice and solid. And the only thing I'm kind of worried about, but not totally concerned about, is this cap will sit between two vacuum tubes, so it will get pretty warm in there. But this is a 105 degree C cap, and it'll be easy enough to change if we need to. Okay. More N2. There it goes, joint just wetted. Now what we're gonna do, I really want to work faster than this but I'm doing a little bit because I'm doing this on camera. But I would really prefer to be working a little bit quicker than this to keep the heat down in the joint, but we have a resistor and a wire, so that's not totally, we're not overheating it and killing it, which isn't bad. This is going to be hot and pokey. Take a look at this getter on these tubes. Looks like there might be a little age on those, but not too terrible. That one actually looks okay. These tubes are branded RCA. This is a 6U8A. Nothing major there. Plenty of those if we need a new tube. But this one looks all right. We're going to see how it works in circuit. Check a couple more, just to be on the safe side, but we do this one at oh, nice, they're labeled. This is the 6DJ8. Tube complement in this unit is AmpereX and RCA, but this one looks all right. Another 6AU8. Yeah, so this doesn't look like it's terrible. I'd say a low-ish time. This had some time on it. It's been used, but it's been very well cared for. So before we fire this up for the first time, I'm going to get these two capacitors replaced. This one is just a meter buffer cap, so it slows the meter movement down. Not 100% sure what this one's bypassing, but it's a electrolytic as well. 25 microfarads, 6 working volts DC, so no problem there. And then the meter movement. So we'll get these caps replaced, and then I will bring you guys back. Okay, I have the two capacitors swapped out. I did have a 6.8 microfarad capacitor to go by the 6. However, it was a 5 volt, and all I had in stock was 100 volts, so that's never going to go bad again. Same thing over here, much beefier voltage on this cap, which is going to be totally fine as well. Let's spot check these caps to see if they needed some replacing. I have a sneaking suspicion these are not going to test well. Alright, so this is that one that was threaded through the chassis. This is supposed to be 6.25. 926. That's not happy. This one is supposed to be 25. 31. And this one is supposed to be 6. That one's all right. So definitely needed 2 replaced, but they're out now. We got other ones in. I think we're ready to put some power to it. Okay, here's a power cord we made up. This is way too chungus for this particular unit. There's nowhere near this much wattage, nor this much length. So it's all right, but not necessary. So here we go. Let's see, Variac is down. I have 0 line voltage right now on the power meter. This is hooked up to the isolation supply. I'm curious if this thing actually has an off switch. I don't. Oh yeah, it does have an off switch. The main knob, power off. I have not cleaned the switches yet, so before we really get into the alignment and the calibration, I'm going to need to service the switch pack, but we're going to put some power to it, see what happens. For right now, because it's been sitting for a long time, I'm going to hit it with about 50 volts. Actually, let's bring it up slow. So we'll click this on, and nothing should happen, which is true because we have no voltage. Okay, I have 2 bulbs switched in on the current limit and the variac. I can watch the trip light that we fixed in another video to see if we have some current. All right, we're drawing a little bit. $50 volts. Are we getting any tube glow yet? Rectifier shouldn't strike at 50 volts, I don't think. Let me dim the lights in the lab. I see a little bit of heater glow. Pilot light's very dimly lit. Bulbs are off. Give it a little bit more. Bring it up to about 80. There we go. I have needle deflection. So we should have had the rectifier may have well, I have needle deflection, so the rectifier had to have struck. Just can't see it because it's dusty. So I'm going to let this sit. We're drawing about 15 watts right now, but the voltage keeps climbing. Coming through the isolation transformer. Bulbs are on very dimly. So we're just going to let this run for a little while through the magic of the camera. You guys are going to be here real quick. For me, I'm going to have to sit and wait. But we have a bit of life. And just for grins, I can zero the meter. So I can zero it out even at 67 volts line voltage. Now I am seeing the line voltage is climbing slowly, which means the current is dropping slowly. So there is some stuff going on here, and I do want to let this process run. I don't want to overdo it and pop a tube or something like that before we're ready. So all we have left to do is give it some time. Okay, it's been running for a little bit. Let's see if we can punch it up. Actually, it's been running for about an hour. Let's see if we can punch it up to full line voltage. Twist this knob here. You guys will see it. Bulbs are lighting up a little bit more. I need to come down. There's 117 on the variac. Now you're seeing the drop on the bulbs, the isolation transformer, all kinds of other stuff. So bulbs got a little bit brighter. Here's what the current limiting bulbs look like. The camera is making them look brighter than it is. But I'm about to kick this over into bypass, which will give full line voltage out to the unit. Here we go. No smoke. Nice pilot light and good glow on the side, so everything is kicking pretty good. I threw the covers back on just to keep it warm, but also just in case the lab cat decided to sniff around. I did not need her nose sniffing the B+. So this is looking really good. I'm going to let this burn for a little bit more and see how it's going. And then we'll figure out what's next. Okay, I have the unit hooked up to the Delta standard, and we're on the 30 picofarad range. We have 0. I have the oscillator zeroed out on the meter, and we're going to kick it up to plus 10, see how it's measuring. This has been online a little bit for at 110 or 117 volts, which is what it wants. So we'll go to plus 10. And it's reading a bit high. So not surprising, we replaced some components, and this hasn't had an alignment in forever, I'm sure. So not awful. Plus 30 I expect to be a little off the scale since plus 10 is high. but we do have full-scale deflection, and we're reading a little high. No surprise there. So the meter is measuring quite well. We do need to clean the range switch and all that good stuff. On the capacitance range is pretty limited, being 300 picofarad is where it tops out at. But on the inductor range, it's actually a little more useful, which is why I want to get this up and running, because this will go up to 300 microhenries. My other meter in the lab that does coils well is this DLM 260, but this only has a 200 microhenry range. So at the moment, this unit, once we get it all aligned and calibrated, this is going to be my best measurement for large inductors going forward, which is one of the reasons why I want to add it to the test bench. So I'm going to conclude this video here, because this will ultimately, in quotes, conclude the restoration. But I saw a lot of people that wanted to see an alignment video on this particular unit, and the alignment process is very convoluted and very confusing. No shock, due to the fact that of the gear that they had available when they had to write the alignment procedure. We can shortcut a lot of the processes with modern test equipment. One of the things that's going to make it much easier to align this is going to be just using a frequency counter, as opposed to triggering off of a time mark generator, watching the scope crawl, things like that. So we're going to be able to shortcut that alignment process quite a bit. But what I'm going to do, so that's easier to find on YouTube and a few other places, I'm going to do that as a separate video. So we'll get the alignment process spun up and going from there. But all in all, great unit, and I'm glad we can add it to the lab. I do want to find the test fixture that goes in that actually you can just slot components into. I don't have that, but I do have the Delta standard, so still need a little bit of stuff for this. Nice warm case. With that, thanks for watching. Let me know what you guys think, and as always, I will see everybody in the comment section between videos and the usual places. If you would like to check out what is up for YouTube, Patreon's running about three videos 3 weeks ahead right now, so nothing is behind the paywall, but the support of the Patreons does go to get stuff to put in front of the camera, and they do give me some guidance as to what they would like to see me do videos on and topics that would like to be covered. If you'd like to be part of that, take a look at the Patreon page, and I will see everybody in the next video. As always, more is on the way.